Okay, this is video 26.4. We'll be looking at what happens when you put a dielectric in a capacitor. First, what is a dielectric? It turns out it's just a fancy word for an insulator. So anything that doesn't conduct electricity is a dielectric. Air is a dielectric. It's the most common thing to be in a capacitor. Now, the reason we put them into capacitors is that they increase the capacitance. Essentially what they do is, if you've got a dielectric between the plates of the capacitor, the dielectric contains polar molecules. And so those will align themselves, so if this is the negative and that's the positive, they'll align themselves so that the positive end of each molecule points toward the negative plate of the capacitor and vice versa. The result is that it effectively decreases the electric field between the capacitor plates and makes the capacitance larger. The microscopic details of it are very interesting, but they're not really on the AP exam. There's a section in your textbook that talks about them if you're interested, but I'm not going to detail them here. What you do need to know is that there's something called the dielectric constant Kappa, which is a dimensionless quantity, and it's a material property, meaning there's one dielectric for glass, there's another dielectric constant for air, there's a dielectric constant for various sorts of plastic. For air, the dielectric constant is just about 1. And the capacitance of a capacitor with a dielectric in it is that constant kappa times C naught, which is what the capacitance would be if that capacitor were air-filled instead of dielectric-filled. So that is the equation you need to memorize. You need to know what the term dielectric constant means. You do not need to memorize any particular values other than the one for air. The other thing is that there's something called the dielectric strength, because dielectrics have this property that if the electric field exceeds a certain value, it breaks down and sparks move through the material. And the dielectric strength is the maximum electric field that the dielectric can take without breaking. That's also given for several materials in your textbook, and it's usually given in units of kilovolts per millimeter. Remember, that is those are units of electric field. A kilovolt per millimeter is 10 to the 6th newtons per coulomb, so it's quite large. And an example, this is problem 36b. We've got a parallel plate capacitor, has a capacitance of 50 picofarads. Remember, pico means 10 to the minus 12. And now it's filled with a material that has a dielectric constant of 5.6. Question is, what is the new capacitance? Well, it's just 5.6 times 50 picofarads, which works out to be 280 picofarads is the new capacitance. So that's very, very easy. But now let's see what happens if the capacitor is disconnected. Remember, that means Q is constant. What happens to the energy stored in the capacitor? Well, the energy in the capacitor, we'll use Q squared over 2C because the charge is constant. C increases, which means that the energy decreases. And specifically, the capacitance increases by a factor of 5.6, and so the energy will also decrease by a factor of 5.6. Question: where did that energy go? That's another thing we'll talk about in class tomorrow. I'll also check question 11 and problem 35. Not a lot of information in this video. You need to know what the term dielectric constant means. You need to be aware of the dielectric strength. And you should be able to see what happens when you put a dielectric in a capacitor. When this shows up on the AP exam, it's usually something like this. You put a dielectric in a capacitor, what happens to the energy?